Resume. All right, we are live and going. So good morning, afternoon, evening, wherever you're watching in the world. Thanks for joining and tuning in. Microphone is working and hot, so there we go. Hopefully we have the better sound quality today as well. My name is Alexander Booth. I'm the head program instructor, head facilitator for the IBM Data Science Bootcamp. Been doing this for almost a year now, so got a couple of cohorts already through to the finish line, and excited to kind of do the same here for this one. Yeah, Karen and I were actually just talking about the group that just graduated, how like great they were, like all the attention we were get like they were giving the class, the great questions they had at the end, and the capstone projects they've submitted. So, and hopefully, kind of as this boot camp matures, we get some more participation in the forums and on the live sessions. When more people are involved in asking questions, I think we all learn, especially with our different backgrounds and just thought processes and the way that we learn. So, quick reminders here, shameless plugs. Try and participate in the weekly discussion forums if you are able to or have the time. There's some weird ones in week two's discussion forums, just by the way. Hopefully, you may have seen this. I forget that we never updated the question for discovering Python. So the question here is actually the web scraping question, but I put some thoughts there around just my opinions on ethical, legal, and technical things about web scraping. So we'll talk about that a little bit later. But yeah, the more you can participate in either the lounge, just ask us questions, make sure you see what I post, including the recaps and the videos and Karen's great resources as well. A lot of good resources coming your way there. Just give it a like just so I know you see it, or just write something down if you want to participate. Karen and I log in every day, so we love when there's something there, but otherwise we're just checking, just make sure that y'all are still okay out in the ether. We can follow along in the grade book and stuff, but the more participation we have, I think the more you'll get out of this. One thing that I love about these types of boot camps is the live in-person reality of it. Like I am a real person, obviously talking to you. We have this live. I log in live. I run the notebooks live. I run every week and all the content live as well. So you're not just taking this like a Coursera or Udemy class. Like you have me and Karen with real industry experience and kind of real knowledge on these topics. So definitely use us as a resource as it is included in your tuition, right? This isn't just an asynchronous class. Cool. With all that housekeeping out the way, we are in week two. This is the live session for week two. Remember last week we kind of had that questions around the what week we currently were in. And again, that was just an issue on the campus side. I think we released module one at the same time as the orientation module, which is why everything looks like it's a week off. Orientation module was supposed to start on April 8th, week one on April 15th, then week two on April 22nd. So that just gives you a week ahead, I guess, to review the content if you want to. But don't feel like you need to be working on week three at all until this upcoming Wednesday or Thursday or even this upcoming weekend. All right. So let's kind of dive into the topics and content here. And then I have a few notebooks that I want to live code out today. We'll start with some of the basic Python stuff, and then we'll move into the web scraping, data engineering, and data manipulation at the end of the session. So yeah, let me load up the lounge here for week two. A couple things to review here. For module two, the idea is to move from transition from thinking like a data scientist into actually doing data science work. We're mostly going to be thinking about what it means to be a computer scientist, right? Or what is computer programming? I like to say that week two, we're taking off our data scientist hat for now, and we're putting on our computer scientist hat instead. But we will relate computer science and the idea of writing programs and automations back to data science at the end of week two. So we're mostly going to be starting with Python fundamentals. We'll learn the four key tenets of computer programming, and then we'll work our way into using real-world data science libraries like Pandas and NumPy at the end of the week. We'll be using Python throughout the rest of the boot camp. We'll have a little bit of we'll have a lot of SQL kind of thrown in, especially starting in week four, and then we'll also start implementing some front end languages, HTML, JavaScript, kind of that stuff when we start talking about interactive data visualizations. I was actually talking to a principal data scientist the other day who was telling me that he only creates visualizations in D3, which is a JavaScript library. And I was like, wow, look at you. It's fancy, man. And then it came out that he actually had Claude Code do it all for him. And I'm like, okay, well, that works as well. So, but you should still, as data scientists, be familiar with more exotic tools and languages out there besides Python, even if Python and SQL are the core ones in this class. There's a lot of notebooks in week two. So again, big ideas is just about exposure and building familiarity. You don't know what you don't know. So if you're coming into this with minimal coding experience, being exposed to all these different ways that coding and programs and automations are built will give you that familiarity. And fluency in the language and a new tool comes with repetition. So don't be too surprised. Don't feel like you're behind if you don't know much about Python or understand exactly how the language works. Over the next 10 weeks, you'll be writing a lot of Python code. And so you'll that fluency, that practice will come, especially in the later weeks as you get more experience and exposure to the language. We've all started from somewhere. Karen and I, like we both have that's like horror stories, but I remember well, like not knowing how to write any code at all. And this was even before AI, so I had to like look it up on Stack Overflow and fix all my issues myself. Can you believe it? Crazy. Anyway, by the end of this module, we'll be writing basic Python code. You should also be able to read code and understand what it's supposed to be doing, what you're telling the computer to do. We'll tackle the four big principles of computer science: variables, data types slash data structures, um, conditionals and loops slash functions. So we'll hit all of that this week. And then finally, we're going to be doing some basic data engineering, data cleaning with Python. How do we get data from an API or web scraping? And then how do we start manipulating it? Note that week three, the one that's coming up here next week, is all data cleaning, data engineering, data extraction work. So everything that we're doing in the second half of week two or the last 30% of week two is all week three. So feel again, if you're feeling like you don't know much about coding, that's totally fine. Just pay more attention to the principles of computer science work this week, and we'll dive into the data engineering stuff in next week. Let's see, big idea here. Python is going to be the bridge between data and analytics, and then also tying that back to automations. Once you're comfortable in Python, the sky's the limit, basically. Order of operations in Python's really good. This is what Karen put in here about PEMDAS, about how transformations, especially arithmetic transformations or feature engineering works in code. A lot of confusion around parentheses and brackets. My advice, always work inside out, left to right. So you start inside of your parentheses, compute all of that, and then once you don't have any parentheses left, you go left to right in terms of kind of the multiplication, division, all that good stuff. So, let's see, other good use case, other good resources. Google Python's class is really good. W3 Schools is great. Kaggle.learn or kaggle.com/learn. You'll see all three of these thrown around the class over the next few weeks as we provide additional resources to supplement your learning. I uploaded a video last weekend about just recapping week one and previewing week two, so feel free to watch that on your own time. Let's see, we'll be for week one, thinking like a data scientist, understanding the data frameworks. Week two, we're going to be reviewing how to code and then how to move that into data collection. So yeah, big ideas. Don't memorize syntax. Don't feel like you have to do every notebook. The only thing that's graded, remember, is the end of week quiz. You have 9 of those end of week quizzes, module 1 through module 9, and then the capstone project, which is 70% of your grade. So technically you don't have to talk to us in the forums and you can watch all these videos or not. But again, the more you put into this, the more you'll learn and take out of it. And that's the pattern we've seen across the last couple of boot camps here. Finally, if you have issues with the IBM notebook environment, then please use Google Colab or just review my notebooks on GitHub, just to make sure that we don't have any barriers or blockers in your learning. And then please talk to us, or at least give us a thumbs up so we know you're out there and doing all right. Again, Karen and I, our goal is just to support your learning. So however you want to be supported, just let us know. But the occasional thumbs up at least lets us know that you're participating and progressing through the course. All right, let's dive into some of our notebooks here. So I'm going to start by actually loading up. Which one do I want to start with first? I want the data types one. Do. I think it's this one. I already forgot. Maybe it's this one. Oh, we should go all the way to the notebooks at the bottom. I think it's 214 is where we'll start. All right, so again, like I said, we're going to start for the first half an hour or so on just principles of data science, data coding and coding, or computer science and coding. And then the last half an hour, we'll do kind of the data engineering work. And then the last 15 minutes, we can work through the quiz or open it up for questions. All right, so we're going to work through the data types example. So remember, let me see if I can pull out my four pillars of computer science. See if we can find it. Maybe that's a little bit too hardcore for me. I was looking for the four tools. I don't know. I gotta find I gotta find one of these images or just generate one of my own. Anyway, with coding, I want you to break it down into four pillars, or you got four tools in your tool belt for working and writing with code. So the first one is going to be variables and data structures. So this would be like, what is a variable? What is a data type? What is a data structure? How do I organize bits of information into objects that can be used in more complex tasks? Your second is going to be conditionals. This will be your if-else statement. This is also known as your control flow. The third is going to be known as iterations or loops. How do we do a bit of logic multiple times? We'll talk about while loops and for loops. And then finally, the last pillar is going to be functions and classes. This is more of a complex pillar or tool, but it's mostly around the idea of don't repeat yourself. If you write some logic once, don't write it again. Save it off as a class operator, as a function, and reuse that logic in other programs as needed. So we're going to start with our first pillar here, which is going to be this idea of variables, data types, and data structures. I usually classify this one as just like variables and data structures. But we'll start with data types. So note that in Python and also in many coding languages, when we save off a piece of information into the program, it's going to be stored as some kind of data type. Your most basic ones of these are going to be numbers versus text. For numbers, we can either save it off as an integer, which is going to be any counting number, even negative numbers, and then a float, which is just a fancy name for a decimal. Note that decimals as a data type usually have three names in computer science, which is dumb, but computer science, it is what it is. So you have float, double, and decimal, and I put that in the Zoom chat. All three of those mean the same thing, basically, of a decimal data type. There's some nuance there before Karen, I know, it's like chimes in, and you can definitely put some resources in this in the Zoom chat. But I think there's some nuance around like how long of a decimal you can have, where floats and doubles may actually restrict how big the number of decimal places you can go is. But for the high level purpose of today, you can think of saving a number off as a decimal or as a counting number. On the text side, the data type is going to be called a string. So these are three of the big ones you should know: string, integer, and float. I'll give you two more bonus data types that you're going to see in the boot camp. The first is going to be a boolean, which hopefully I had something down here. A boolean is going to be essentially just true or false. So if something is true, then do some work, otherwise do something else. So again, true and false is going to be a Boolean object. Note it can only have two values, true or false. And then the last one that I'll give you is a date time. You'll see date times a lot in many coding languages. I don't think they're in every language, but they're in a lot of them. And a date time is exactly what it sounds like. This is a date object. It's not just going to be a string. It's not just going to be a number. It's going to be a time zone offset, a date, something that we can manipulate in a time series way. And Python does support the date time data type as well. So let's go ahead and just run this notebook and fill in kind of the exercise at the bottom here. I'm going to clear outputs of the cells and restart the kernel. It's always a gamble when I restart the kernel. So we'll see if this actually clicks over. I should have just cleared out, but I should have just learned my lesson. Don't mess with the kernel. I believe in you, IBM. Well, starting off hot today. There it goes. All right, hopefully that's alive. All right, so let's just kind of work through a few of these. So we'll start by showing like what is an integer. So here's the number 11. The number 11 is going to be an int. Int stands for integer. Same thing with 2.14. This is a decimal number. If I run type on it, it's going to come back as a float. Same thing for a string. This is a text object. Note that text can be used and wrapped in quotes. Either double quotes or single quotes will work. However, you'll see double quotes used most often because sometimes text strings can contain single quotes as like an apostrophe, for example. So if just an example, if I have like the phrase like "Hello, Karen's Python," you'll note that pet Python. You'll note here that because I have a single quote, I have to use double quotes for my string, right? Otherwise, it won't come back correctly. If I use a single quote here, it breaks because it thinks that I end the string at the apostrophe when I don't. So either double quotes or single quotes works, but you'll most likely see double quotes used more often. Uh, cool. Yep, we can look at these again. And let's check the object type of 12.0, and that comes back as a float. Cool. Like I mentioned earlier, integers can also be negative numbers or zero. Floats can be any decimal. And this is kind of what we're talking about with the idea that floats can have like different, I guess, precision when we talk about the number of decimal places. So this actually gives us like what the max numbers can be for a float. And there's actually a lot of information. These are some big numbers. So yeah, I think it can have like a maximum of 15 digits or something. I think that might be the big one in terms of precision. All right, to convert, we can convert data types to one another by just casting it. This is known as casting when we cast a new data type around an existing one. So we can cast 2 to a decimal, and this will obviously just turn and add in that decimal number. Same thing for casting a float to an integer. Notice in this case, we just truncate it. I don't think it rounds. I think it just truncates the decimal. So even like 1.9 will be trunked to 1. So something to just keep in mind. Strings can be cast to numbers, but only if they actually are a number. Obviously, this text right here is not a number. And yeah, honestly, if your numbers are strings, then that's an issue, and that'll take some work to fix. Cool. Again, we already talked about single and double quotes. We can convert numbers to strings really easily just by wrapping it around with the string function. Booleans, we talked about Booleans already, true, false, and they're going to come back as a bool. They can only be true or false. If you try casting them to other data types, they're going to turn into ones and zeros. You can't really do much with strings and Booleans yet. Let's just do some quick hello world exercises. 6 divided by 2, that is going to be a integer as it'll result in the number 3. Let's try it out. 6 divided by 2 should be an int. Oh, I guess it came back as a decimal. Maybe I'm just dumb. 6 divided by 2. I guess it comes back as a 3.0. So there you go. That's interesting. Obviously, it comes back as a float. 6 double dash. This is a remainder. Yeah, so I should be remain. Maybe modulo is a different. Modulo is percent sign in Python. I thought modulo was double
Modulus is
dash.
like the remainder. So if you're doing six with a like that, you get three. But if you do module two, it will give you one. It will give
Yeah, I
you
guess that's integer
the
division. A double slash is
remainder.
modulo in a couple other languages too.
You don't go
Anyway,
to yeah. If you do the percent sign, you'll get one
yeah,
because
or
you'll get
zero,
the
right?
remainder.
There's zero residual or remainder.
Well,
But yeah,
two actually you'll get zero there. Six divided by module three, you'll get zero because it's evenly divisible.
yep.
But you had seven with the integer division for two, then you'll get three, but then you would have a remainder of one, and that would be the
Yeah.
module.
So I wanted to call out double equals means equality check. So we're checking the data, we're checking the content of each side. Remember, a single equals is going to be assignment, but double equals is going to be comparison check. So hello does not equal world, but this is a comparison check. So is it true or false? This also will come back as false, which is a boolean. I'm not going to bother with the other ones of these. So big idea here, you need to understand your idea of a data type. As we start using and passing information into Python, it's going to be one of, or it's going to be stored. Its information will be stored as varying data types. And depending on the data type, there are different transformations you can do, right? Like we can add up integers and floats, but if we use add on a string, we're going to end up with appending. We're going to append more content to the string instead of just adding them itself. I guess I'll show you a quick example of that at the bottom uh, before we move on. So yeah, what I wanted to show, if I do like 1 plus 1, that is 2 because they're both integers. But if I do 1 plus 1, that's 11 because it concatenates them as text strings. It's, there's a few more. I want to like fly through a few of these because there's a few that I want to cover today. So we did data types. The next one that I want to do is going to be list. So let's say I think that'll be the first one in 2.2. Hopefully it's this one. So now let's move into, again, variables data types. Let's start thinking about data structures. Actually, this is the variable one. Yeah, variables, all they're doing is just assigning, notice with a single equal sign, we can assign to a human readable name the result of some bit of information or some transformation to that bit of information. So for example, total minutes is going to be the variable name that we can then use in our program, and its value is going to be 43 plus 42 plus 57. I'm not going to run this notebook. This isn't the one that I wanted to show, but it's good to know. Let's go to 223, which should be lists, hopefully. Strings. I don't care about strings either. Let's try 2421. Tuples, we don't care about tuples either. Long story short about tuples, tuples are an immutable list. What that means is that it's a list that cannot be changed. But I start with lists, and then we'll talk about the other data structures at play here. All right, so we're into lists. We'll let this kernel click over, and then I think I'm just going to clear outputs instead of restart the kernel. All right, so now that we have variables, we have data types, we understand how information is stored and can be used in a program. Let's talk about the second half of our first pillar here, which is data structures. Data structures allow us to organize and store multiple bits of information in a single object that can then be used and transformed in downstream tasks. So things like a list, I want to loop through each list. For each thing in my list, I want to do something. For each row in my data frame, I want to divide by 6 or something, right? So data structures allow us to store and organize bits of information. There are four main data structures you should know, and we review all of them in the media sets, but I'm only going to cover two big ones here in the live session. So the four data structures you should know: lists, tuples, sets, and dictionaries. So we'll start with a list because the list really is the backbone of all of these data structures. And note that these data structures exist outside of Python as well. Everything we've covered so far, data types, variables, data structures, whatever programming language you're in will have some form of these concepts. So with a list, essentially we store elements or items based off of an index. So things in Python start counting at zero. So zero is my first index. At position zero, what is the thing in my list? In Python, a list can have multiple data types. Note that is not true in all languages. In some languages, you have to have lists of integers or list of strings, but in Python, we have a list of multiple data types. So let's compare our list L here to what we now know. This list L contains three data types, string. So we only have one person online, but I'm gonna say this is a float, and then this one will be an integer. So notice the array of data types we have. And at position 0 is the bodyguard, at position 1 is 7.0, and at position 2 is going to be 1992. So again, this is going to be a type of list. Note you can use negative indexing if you want, which basically reads the list backwards, but for the most part, we read forwards. Note that even a list can contain other data structures inside of it. In this case, we have another list here as well as another tuple. So this is where we can create nested data structures, which allows us to host pretty complex data types. I'll show you an example of that in a second. If we just want to get subsets out of a list, we can use slicing to do that. So in this case, I only want elements from position 3 to position 5, and position 5 is excluded. So looking at my list here, 0, 1, 2, 3. We're going to bring back BG at position 3. We're going to bring back 1 at position 4, and the last number here is excluded. Notice they could have also just done 3 colon, and that's implied to go to the end of the list. But whatever. We can add more items to a list using the extend command, or we could use the append command. Append will add it as the existing data structure, though. Notice we have a third element that's a list here, while extend actually took the items out of its data structure and appended those as a flattened structure to the original list. Cool. What else do I want to show here? Lists are changeable. Mutable is just a fancy word for being able to be changed. So contrast that to tuples, which I mentioned at the top, are immutable. They cannot be changed after you create them. So note here what we're doing. We are finding position 0 in my list, which is disco. We're using a single equal sign, which is assignment. So we are assigning the value of hard rock as a string to the first position of list A. That's how we can read this code here. And now after the change, we see that is actually what occurred. We changed the first item from disco to hard rock. You can also use delete. I don't use delete very often, but you can do it. That deletes a index. Note that it resets the index though. So now 10 becomes a bracket 0, right? The first item in list A is now 10. So that's just where delete can get a little dicey. If you run it a bunch, it could just delete everything in the list. Um, let's see. If you split strings, you end up with lists. This can be based off of characters like white space or commas. You can deep clone lists. I think both in this case, this is not a deep clone. What I mean by that is both variable names are pointing to the same place in your computer memory where the list is stored. That's typically known as a shallow clone. There are other ways to do deeper clones, though, where we end up allocating memory behind the scenes as well. Cool. I'll leave the task as an exercise for the reader, or you can just check my backup in GitHub where I ran all of these earlier in the week, just because I want to get to the fun stuff. All right. The next one I want to show is dictionaries, which I do actually have here. I'm not gonna bother reopening it. I think this is one of the next ones. All right, so let's recap the other data structures, right? Lists, tuples, sets, and dictionaries. Tuples are an immutable list. They are lists that cannot be changed. Sets is exactly what it sounds like. It's a unique set of objects. It's a unique list. In a set, I can only have one item in there, one value in there, uniquely, right? So technically, all of these lists that we created could have also been sets, but the difference is that like a set is completely unique. If you try to add in a new element, it's going to uh, throw an error. Cool. So besides lists, tuples, and sets, the main other data structure you need to know is a dictionary. Dictionaries are more unique to Python, but there are some other ways of talking about them in other languages. You may also hear dictionaries called a named list, if you hear that floating about in your studies. Essentially, what's a dictionary? What is a named list? Instead of using these indexes of 0, 1, 2, 3, so we're using these numeric indexes, a dictionary uses a name, hence a named list, or uses a label. We're going to call them in this class key value pairs. But essentially, instead of looking up the position by its index, we're going to look up an element's value by its label or by some kind of text key. So we'll do a quick example. So here is a dictionary that we have here. Notice that it's instead of hard brackets, we're using squiggly brackets, and instead of indexing 0, 1, 2, 3, we are using labels, text strings as labels here. So key 1, key 2, key 3, key 4, key 5. Notice that technically dictionaries are unordered. But yeah, they're mostly ordered. I'll let Karen put some more resources about that kind of in the chat. But yeah, essentially, like we could go through the first key value pair, the second key value pair, but usually you're going to think of it as we're going to be accessing information by the name or by the label or by the key. Again, I'm using kind of all the syntax or all the vernacular that you'll probably hear about this. Because, like I said, I hear named list quite a bit, and that's very, very similar to dictionaries. So the dictionary, if I'm going to be extracting the value of position key 1, we go to our dictionary, we look up, just like a dictionary, we look up the definition of key 1. Key 1 has a definition or a value of just the number 1, and so that is what we're going to return. Technically, in this case, they have a tuple as a key, which is crazy. Don't ever do that. That's insane. Just stick to just strings and labels will be kind of the definition of your keys. Technically, keys can be anything that's immutable. But yeah, this is crazy.
Not really.
Anyway,
I've had good use for that. You have
yeah,
a combination of pieces of information, and so the unique key is can be two different things in a tuple, where you have like let's say you had numbers and words or
yeah,
something. I don't know. So, but I've definitely have had occasion to use that. Thing is, where you get trouble if
interesting.
you try to use a list, then you get an error because it will say it's not hashable.
Yeah,
Basically, anything that can be turned into a hash can be used as a key. In other words, it can take
yep.
whatever it is and make an integer, and it uses it as an index into a table where it actually stores the information into an actual list that stores the information. Hence, that's also sometimes known as a hash table.
Good call out. Let's start looking at how dictionaries are really used in the real world here. And then we'll kind of break this down into why I'm spending so much time talking about lists and dictionaries. But here's a dictionary that we have. It's got the release year of a bunch of albums. And we can see that here's my dictionary where the key is the name of the album and the value is the year that it was released. Honestly, that probably should have been an integer. Notice that they cast them to a string in the definition, but whatever. Anyway, so let's look. Thriller was released in 1982. Bodyguard was released in 1992. And we can look at all my keys, and technically we can look at all my values. And I'll also go one step further and probably say we can also look at our all of our items. There we go. If we look at all of our items, you'll see all of our key value pairs together. And this is turned into a list. Again, this is kind of hacky. But now we can start adding more information to my dictionary. And now start thinking about how could look as a like a data frame or a CSV or an Excel workbook. These could all be individual rows, right? We could have a data frame, a CSV where column A is just going to be my albums and column B is going to be my release year. So now we're starting to organize this a little bit more like that Excel data frame. And I'll actually posit to you in a second here that with lists and dictionaries, we can create the foundations of a pandas data frame. Yeah, one of the reasons also why, before we get into data frame stuff in the second half of the lecture, just how real world data looks. This is a public API that I use all the time. Basically, it's just like the current, I guess I need to give it a date. Yeah, let's see if this comes back. No, womp womp. I'll just do this one. Basically, this is an API that you're gonna you'll be hitting a different one later on in this class. But look at how it's organized, right? We have these squiggly brackets, and then we have my labels, my keys, which are going to be text, right? In this case, we have copyright, which is a string, and then we have a second key, which is sports, which contains a list. And inside of that list are individual dictionaries with more key value pairs. And looking at it, these could all represent rows, right? Where Major League Baseball could be ID1 and have these columns: ID, code, link, name, abbreviation, sort order, active status. And then maybe the Korea Baseball Organization, the KBO, that is going to be another row in my data frame or in my workbook. And it's also flat. It has the same 7 columns here, and we can see the new values for this. But now we can start thinking about, all right, dictionaries and lists can be a way to structure and organize relational tabular data, and in some cases semi-structured data. And you'd be absolutely right. And that's going to be kind of where we're going in the second half of week 2 here, is how do we start taking these foundational data structures and data types. For example, I'm seeing integers, I'm seeing booleans, I'm seeing strings. I love it. That's why this is also relevant. And this is a real world, a public API, right? So how do we start ingesting this, understanding its structure, understanding its types, and then start using it for data science purposes? All right, before we get there though, I'm going to pivot back to our media sets here, and we're going to pivot into kind of the last couple pillars of computer science, which are going to be iterations and conditionals. And I don't know if we talk about functions much in week 2, but if we do, I'll leave them as an exercise for the reader. 3.1 and 3.2. Let's see if I can find them. 3.1, hopefully. Give me a conditional. Functions and classes. I guess we could save that for later since I did talk about them. Let's try 2.6. I wish I could just actually just check my notes. Oh, no, they're in 2.6. What's 2.5? Oh, sets, dictionaries, and then classes. All right. So let's go into 2.5 here. And maybe you'll get a bonus lab on functions by me while we're here live. Again, feel free to drop questions in the Zoom chat too. That's what Karen's monitoring. So if I'm ranting too fast, like definitely feel free to, oh, definitely feel free to just yeah, put something in the Zoom chat, interrupt, etc. 2.6.2. Maybe I'm a little bit out of order on mine. But 2.6 is, I'm just dumb. 2.6 is loops and functions. Conditionals and loops. There we go. Hooray. Huzzah. We did it. Go, good job, class. We organized our way through the campus. All right. So these last couple, I'm just waiting for my kernel to click over before I clear the outputs. But yeah, these last couple of notebooks here, it's gonna take us away from the nouns of computer science, and the nouns are what we do logic to. So your variables, data structures, data types. And now we're going to move into how we start writing full programs with verbs, transformations, and ways to interact with those bits of information. So the first is going to be known as conditions and branching. This is also going to be your control flow. If something is true, then we do some form of logic. Otherwise, do something else or wait to do something else. I don't say, yeah, my kernel's mad at me. Womp womp. Which one was this? 262. Let's see if this connects. I think this also starts being mad if we have like too many kernels active at a time. But I'm hoping this clicks over. Kernel status unknown. Womp womp. Yeah, it's definitely online on this one. Maybe not. Oh, and I'm trying to restart the kernel. See if that helps. I wish there was a way to like just look at like active kernels and then just like kill them from the UI.
What if you stop the kernel over on the left? Click the little square thingy. Yeah. And then,
Open
yeah,
tabs, kernels.
make sure,
Shut down all. There you go. Let's see if that helps.
yeah, shut everything down and see if it'll be happy.
Doesn't look like it.
Oh, that says it's busy. Maybe
It's
it'll
like
come.
initializing.
Now it's back to initializing. It's been a little slow, I noticed earlier.
Oh,
So
there it goes. Love it.
guess it's been
Maybe
a
that
little
worked.
slow earlier.
I did it. I did a Control Shift R to do a hard refresh of the browser cache too. All right, let's look at conditions here while we go. So conditionals, you should definitely know all of these different signs. Notice that depending on your language, the syntax may change, but the logic does not. For example, we brought up JavaScript earlier. JavaScript has a strict equality with three equal signs, which is kind of crazy. And then in Microsoft, if you use VBA, not equals is actually like less than sign, greater than sign. It's kind of weird. But anyway, the logic exists in all languages, even if the syntax is different. And that's a theme I want you to take away from week 2. Don't memorize syntax because depending on your language or problem, it may change a bit, but the logic to solve those problems are usually consistent. So again, here, notice that first we use one equal sign for assignment. A is our variable, 5 is our integer data type value, and then two equal signs is a quality check. Does 6 equal A? The answer here should be false. Good job, class. Next, greater than sign is 6 greater than 5. That is true. And notice that everything being returned here is a boolean. That's going to be important for branching and routing. 6 does not equal 6. That is false. We can also compare strings. Obviously, AC/DC does not equal the bodyguard. And let's see, compare characters. And then here we go. Is the length of this string greater than the length of this string? That should be true. Definitely don't memorize ASCII codes. That's crazy. All right, so here's something important for how do we actually use conditions. We use conditionals in control flow or branching out different logic. So in this case here, we have a branch. If the value of age is greater than 18, we do one thing, and then after everything resolves, we do another. In this case, we only print move on. But if I bring back age equals 19, I'm using control forward slash or question mark on my keyboard to uncomment. This comes back as you can enter. This is true. This is true. So we trigger this branching code. and we execute it, and then we execute this one. So this is a good little graphic of kind of what we're doing with branching. Here's a more exotic one. If age is greater than 18, print you can enter, otherwise go see Meatloaf. And in this case, our age is 19. So we hit you can enter and then we go to move on. But again, if I change the value, we hit the second branch. So now we print go see Meatloaf and then move on. Else if adds additional branches to our logic. So again, here we're going to be checking greater than equals to and then all others. So if age is equal to 18, 18 is not greater than 18. So we go to the second branch. 18 is equal to 18. So we execute this command and then exit the loop. Exiting the loop, we then print move on. So this should come back with go see Pink Floyd and then move on. Notice that move on is always printed because it's outside the conditional check. Here's another example. We're checking against the album year. This allows us to categorize by decade if we wanted to. Let's see here. Syntax, notice the colon and the tabbing. That's going to be the same for any kind of code execution block with this workflow. In this case, album year is 1983. We trigger the first if statement and then the final or then the normal rest of the program. Other ways to do conditions is with and, or, and not. And everything has to be true, or one thing has to be true, and not nothing has to be true. That's kind of your easy ways to think about it. So in this case, 1980, this is greater than 1979, and it's also less than 1990. So this should hit. It does. Album was in between 1980 and 1989. Cool. All right. For the quiz on conditionals, I like this, I think. Oh, no, this is kind of dumb. So yeah, we'll skip over this as well. We'll leave this as an exercise for the reader to look at as well. All right, I'm gonna do loops because this is in the same section here, and that should give me enough time to do the project and the uh, quiz questions. All right, so let's do loops here. Loops is going to be our other big tool belt in our ways to create programs. Again, we've covered variables, data types, and data structures. We've covered conditionals and branching. We're going to cover loops here, and then I may show the functions code, and then we'll get into it. So with a loop, this is basically how do we do and iterate through logic and do some form of operation many times. Again, an example with this could be for each element in this list, right? For each value in or for each dictionary key in my dictionary keys, right? I want to do some form of logic, some extraction, some transformation on it. We can do that with a for loop or a while loop. The main difference here, a for loop will execute for a specific number of times, 10 times, or for each thing in my list. A while loop will run until a condition is met. While something is true, then execute this code. And as soon as it stops being true, then we break. This is why you see some pretty great memes on the interwebs. I like the while one equals one. It's like these are pretty funny. It's like, well, I like this one. This one's pretty good. So it's like while one equals one, this will always run forever. While true will also always run forever. And now we're getting crazy. While not true equals not true. This also technically is true, right? False does equal false. So false equals false resolves to true. This is also while true. But notice that we're so exotic. We're so high class with our crazy while statements. Or something like this. While one is greater than zero, we're going to print OI. This is always true, so this will just print forever. So this is kind of the risk you take with while loops, right? Is like, yeah, this is a good one too. You can't just print money infinitely while true, print money. This will also just run forever, right? So that's kind of the problem with while loops, is that they could just run forever. And that's something that we need to watch for. This is the Module 2 Lounge, right? I'm just gonna drop this image.
Yeah.
Stolen memes. There we go.
Make sure if you have a while loop, always have some way out. So if nothing else, you have to have a break statement. Otherwise, you'll just go forever and you'll not. Yeah.
So for those students not watching the lectures, they'll have no idea why we just posted that random meme into the lounge. But there you go. Cool. So here's a quick example of how this actually looks like in practice. Range gives us kind of this set of numbers. So to run things specifically, in Python, the three is excluded here. So this is returning three items, 0, 1, and 2. This allows us to kind of iterate through based on that individual specific. So here we're saying that the length of dates is 3. Range of 3 should give us 0, 1, and 2. For I in that list of 0, 1, and 2. So let's say first I equals 0. We're going to grab dates bracket 0, which would be 1982. This is a really cumbersome way to do a list or to do this list here. I would just do for x in dates print x, which will also do the same thing where it loops in this case for each thing in my list, do something. There's a little bit of a nuance between uh, what's known as a for loop versus a for each loop. In Python, for each is implied. For each x in my object, I'm going to do something. While a traditional for loop, you usually have to specify how many times you want it to run. And that's the range example up here. I only want to run this list 3 times, or this loop 3 times. So you can kind of see that how this goes here. For I and 0, 1, 2, we're going to be adding 34 to each of my years. Same thing here. And then here's the actual for each loop. Read as an iteration for each value in a list. For each thing in my list, get that thing, add 34 to it, and then print it out. Cool, cool, cool. Cool. I like this ish. I kind of like it. What we're doing here is we're going to be looping through the list and we're going to be changing them all to white. So if this works correctly, this should create a list of a bunch of white squares. Yeah, there you go. So this is kind of fun. Again, usually you would do some transformations like this and create new lists or new columns for your data frame. I'll leave enumerate as an exercise for the reader. Basically, this allows you, it's a hack to get both the index value and the value out of a list. All right, let's do a while loop here for an example. Notice that a while loop will run until the condition is met. So we're going to loop through my list of dates. While the year is not equal to 1973, we do the work. So this should only print out 2 years. 1982 should check, 1980 should check, 1973 breaks the while loop, and so nothing occurs. So we should hopefully get 2 checks. Yes, look at me knowing how code works. Cool. We can force break out of a loop if needed by using the break and continue statement. Break will always break the loop, no matter what. So we're not gonna keep iterating until 10. We found our number 5, and then we broke emergency break glass ceiling out of the loop. Continue skips things. So if the number equals 3, we're gonna skip it, and we're not gonna print it out. So notice that 3 was not printed here. Cool. Here's how this can help with a while loop. Notice here that we skip 3 due to the continue, and we end at 8 because of our break. Uh, leave quiz exercise as an quiz question as an exercise for the reader, or you can just check and compare against my GitHub. Cool. So I'm just checking to see if I downloaded the conditionals. I did. So let's download the loops. And the last one I had was functions, which we'll see if it works. I think that was this one, right? Cool. Let's take a quick look at functions. Technically, functions will be and classes will be the last tool in your computer science tool belt. Big idea here is to not repeat yourself. And that's another good meme image. Let's see if I can find it. In coding. I will not repeat myself. I will not repeat yourself. Uh, yeah. Repetition is the root of all software evil. It's a bit hardcore. Uh, yeah, I'll say everyone repeats themselves in code, though. Repeated code everywhere. Anyway, functions and classes are a way to hopefully mitigate that issue. Get rid of the classes one. I'm just trying to get my thing to reload. Come on, I got two more notebooks I want to do here. Two or three more notebooks. So I may just have to scroll through the functions notebook. Function classes, though, they do exactly what they sound like. We need to mitigate the number of times we repeat ourselves. So in this case, we're creating a function called add, where we have the logic that we want to reuse to define how we want to do addition. And then we can just call our function multiple places. So we are using less code. We are not repeating the logic used to make the addition. We're just calling this function. Same thing for multiply. Maybe we want to create a function to do a square or anything like that as well. So functions allow us to call reusable code. Yeah, so I guess if you're looking at like block one on block two, we can replace them with a function, and then everything should look a whole lot cleaner. There's a lot of pre-built functions in a Python. So some length, we've already looked at a few of those today. Um, yeah, not too bad. And then classes are ways to organize both variables and functions into reusable objects. Python is considered object-oriented programming as an OOP language, but we'll get into that maybe a little bit further down the line. I think when we get into databases and stuff a little bit later as well.
I
But
think,
note that, yeah, go ahead, Karen.
all right. I just add with functions, the motivation is, let's say you have some set of logic to do something, and maybe it's fairly complicated. Now, if you keep repeating that logic in various places in your code, and let's say later you decide, oh, I realize, oh, I have to change that logic, then you have to go and find every place that you had that logic and change it. So if you pull those things out as a function, then you have just one place that you have to change that logic. And that really makes the code much more maintainable and extensible and much more useful for people who come after you who might have to make changes to that logic.
Absolutely. For the last notebook here, I'm actually going to skip the pandas examples and NumPy stuff. Like I said, we're going to do all this in week three in a lot more detail. So just for the sake of time, I'm going to jump to the final practice project at the end of 211, and then we'll review some of the week two quiz questions. And I want to make sure I can run this one live, so we'll crash all the other kernels. So let's kind of start putting all this together. Again, big idea to take away from week two. You should be able to take off your data science hat, put on your computer programming hat. Everything we just discussed from data types, data structures, integers, decimals, lists, dictionaries, sets, and then conditionals and loops and functions and classes to an extent. All of those are fundamental principles of computer science that you should be able to do on in any language. All right, so it looks like we're connected here. Of course, I'm glad this one just worked. Cool. So let's kind of run through our practice project here. This kind of unites kind of what we're going to be doing in week three with Pandas, NumPy APIs, as well as starts tying it back to what we've already talked about data types and data structures and writing, coding, and automations. So let's get after it. Our scenario here is an international firm is looking to expand its business and it wants us to be a data engineer and write a program to go grab the 10 largest economies of the world and do some data cleaning on it. So here is what we're going to be doing. Our kernel's connected, so let's just start running this from the top. I've already done this notebook, so mine may be a little bit more fleshed out than yours on your end. But if you only do one notebook in week two, if you already have familiarity with coding, then yeah, starting in 2.8 and starting with the Pandas NumPy web scraping, it'll give you a head start and the content we'll be diving into in week three. All right, so we're going to load in Pandas and NumPy. NumPy is essentially a library for manipulating matrices. Matrices are just nested lists, and Pandas allow us to interact with data through a data structure known as a data frame. And behind the scenes, a data frame is built on lists and dictionaries. Know your fundamental data types, and all these more exotic abstractions of them just fall into place. All right, so let's go grab our data. This is the URL that we're going to be hitting. We could actually open this up in a new tab if we wanted to. We're going against the web archive, so we all have the same consistent view of this Wikipedia page. It should come back with some tables and charts and things that we want to grab. Sweet. So here's our Wikipedia page. Here's a table, and this is the main table that we want to grab and then do some data cleaning to it. Our boss said he doesn't care about all 200 of these. We only need the first 12 or 15, I think. Let's say a Tuvalu hanging out here at the bottom, but they have the .tv domain. I actually think that most of their GDP comes from revenue off of the .tv. There's actually another one. Like who owns AI domain? I can't remember which yeah, Anguilla. That's not how you pronounce it. Anguilla. Anguilla. I don't know. But yeah, anyway, this is a really fun article. I'll just yeah, tech founder just paid $700,000 for this .ai domain. This is pretty funny. But anyway, this goes back to like Tuvalu, same idea. Most of their GDP was from the .tv um, domain.
Yeah, I was wanting to register a .ai domain for the project I'm doing, but it was already somebody had just claimed it and basically we're
Yeah,
selling it for like $28,000.
it's so expensive now. You can't get a .ai. Anyway, yeah, there you go. Yeah, Tuvalu did a
People just
thing.
buy up, they register lots of likely domains and then they sell them at really high prices.
Yeah. Anyway, we don't have too much time to get too distracted, but it's something interesting. So here's kind of the work we're going to do. Using our pandas, power of pandas, we're going to read the HTML from this web page. We're then going to find table 3, which should be our table. Don't worry about this. You can worry about this. This is a week 3 you problem, not a week 2 you problem. But I wanted to start showing that with a data frame, we can start doing some simple transformations like we did with lists, where I only want to retain columns 0 and 2, and then I only want rows 1 through 11 or 1 through 10, and then cleaning up the columns here. So actually, it didn't like it. Tables bracket 3. Oh, it only had 2 columns anyway. Oh, it found the wrong table. That's the problem. So let's see if we can get the right column here. Um, it found 7 tables. So let's see if we can find the table that we care about. I think it's gonna be table 4, maybe. No, table 2. Yeah, it's table 2 here. I think that looks like what we want. Yeah, there's Tuvalu hanging out at the bottom. So we actually want tables 2 here. Maybe there's some update to how Pandas does its web scraping. So also maybe this is just a bug because table 3, yeah, on the index, maybe this is an exercise for the reader. Um, 0, 1, 2. So 2 is going to be the third index. So it's going to be the third table that we find anyway. So let's swap out 3 for 2 here. And when we run this now, we should be able to see what our data frame looks like. And it looks like this, where we have our country and the GDP that we extracted. And when we look at our .info, Notice that GDP, however, is the wrong data type. It's a string column. And one thing that's also interesting, let me actually show you one more bonus knowledge cell. Just again, to show the relationship between Pandas data frame structures and our foundational fundamental structures. If I call df.to dictionary and I do orient equals, uh, figure out how to orient it. Orient equals, I forget the different values. Is it object? I don't think that's right. So my brain is farting right now.
What is it?
Oh, orient equals, what do I need? I want orient equals
Oh,
uh split. Orient equals records. That's what I want. Orient equals, where are they? And what does this look like? This is a list of dictionaries where each of my dictionaries represents a single row and each key represents a column in the data frame. So this should map pretty closely to what we looked earlier at these JSON API type objects. So I want to kind of start clicking the gaps here, right? How does foundational data structures like lists and dictionaries map back to raw data formats like JSON and APIs, and how's that all tie together into more, I guess, abstractions like data frames, right, or NumPy matrices. So pretty cool. So now let's do some more data cleaning. Let's fix our data types, right? Let's do some, I guess, some feature engineering, and let's also use some NumPy here. So this is actually really interesting because what's happening is that these transformations are using a loop behind the scenes, and we'll show you what that looks like here in a sec. But notice what we're doing is we're grabbing this entire column for each row in my GDP column, divide by 1,000. For each row in my GDP million column, round it to two decimal places. So Pandas allows us to do shortcuts like this. But another very common use case or another very common syntax would be something like for row and df.iterRows, or I'm doing a loop. I want to I guess it would be for like the index rows and df rows. I want to print row bracket country because this is essentially going to be a dictionary lookup. So we can look up the country key in my row and I'll also show you what row looks like here. And then we'll print us a new line at the end of it. So here you go. We're printing the row, which is going to be this dictionary object. And then we're extracting country to get United States. So again, we could just do this as a loop as well. Maybe we do some transformation here to print, I don't know, row my GDP billion of USD. And maybe we're going to just divide that by, I don't know, 100. Why not? So now we're doing transformations within the loop itself, right? So pretty cool. Again, Pandas allows us to abstract some of that away. That's the beauty of Pandas data frames. And then NumPy allows us to do more exotic mathematical transformations, especially in formats like linear algebra. We can confirm that our data types look good and that our data frame looks good. And now we can save this off as a new CSV if we wanted to. Yeah, I wanted to reference here that without this index equals false, your data will start looking a bit funky. Let me save this. So if I use index equals false, notice that my CSV looks normal, but without that parameter, it actually writes the index as a duplicative column here. So just something to watch out for, especially as you start doing creating data sets from your pandas transformations. Again, big idea for week two. If a lot of this went over your head at the end, focus on the beginning of week two, especially if you're new to data programming. All of this around web scraping, APIs, pandas, transformations, NumPy. That's all we're doing in week three. It's a much shorter week in terms of notebooks. It's fewer but heavier notebooks on pandas and NumPy and web scraping and APIs and all that good stuff. That's also why I kind of breezed over it here at the end. The real meat and potatoes from week two is making sure you have a solid foundation and understanding of computer programming principles, including variables and data types and data structures, conditionals, branching workloads, if-else statements, loops, specifically for loops, while loops, and then don't repeat yourself using functions and classes for object-oriented programming. Well, let me just quickly download all these. So I have the backups. Last 10 minutes or so, I want to tackle some of the quiz questions because there were a few funky ones in the week two quiz. So if you didn't get 100 in the week two quiz, I don't blame you. And then we'll leave a couple minutes for questions here at the end. Yeah, week three, look at that. One, two, three, four, five. You only have five notebooks in week three, but each one of them deserves your undivided attention. Unlike week two, where you could have breezed through a lot of the notebooks, I do recommend being specific in week three and spending 20 minutes per notebook, right? And actually spending that time with each workload.
But I also think that if you didn't get through everything in two, you can still use some of the time in three.
That's a great point.
Yeah, so that way, I mean, and you'll be reviewing the things anyway, and those are just applied, and the notebooks in three are just applying the concepts. So,
Yep. Uh, let's go ahead and look at the quiz for week two. I was like, I think Karen, you're gonna just call me out if I mark anything crazy wrong. But yeah, let me kind of work through these on my own first. In
yeah, I got
Python,
it.
what
I
can
got 100. So,
there? Those is a couple typos, right? But that shouldn't
oh
stop you
yeah,
from
I think
getting 100.
there was something that I said. Let me now
Yeah.
if you're
Anyway, let's take a quick look at these. In Python, what can be a positive or negative number but no decimal point? That'll be an integer. Float is a decimal. Complex isn't a real data type in Python. Given the string name equals Emily, which statement would provide the index of 0? E is at the very beginning. It's going to be the first item. Python starts counting at 0. So even though we didn't really review the dot find in the lecture, finding E, that should bring back 0 because that's the position where E is in the string. Three, which of the following code segments would generate an output of a decimal 0.5? As we saw, double slash does integer division. 2 divided by 1 is just 2. 2 divided by 1 is 2. Integer division. 1 divided by 2, integer division is just going to be 0 or 1. So 1 divided by 2 will produce a float of 0.5. Four, complete the statement. Dictionary items can be dictionary items. That's the key value. Key value can have multiple data types. Key values cannot have duplicates keys. Key values cannot just be strings. So the last answer is D. Dictionary items can be multiple data types. What is a tuple? It's a list that cannot be changed. So it is ordered and unchangeable. The only data structure that's unordered is technically dictionaries that we reviewed today. Lists, sets, and tuples should all be ordered. They all start with 0. They're not named lists. What's the output of the following code? If x equals gone, if x equals go, print go. That's not true. Otherwise, print stop, then print Mike. So we're going to print stop because we only hit the else, and then the Mike is always printed. So we print stop, then Mike. Which the value following is the value of x after the code gets run. X equals 1 is 1 greater than 5 is false. We assign false to the value. We overwrite the value of x. So this should be false. What's the output of this? While x is not equal to 2, print x, and then x goes down. So let's just run it through. We start at 5. 5 is not equal to 2, so we print 5, and then we go 5. 5 minus 1 is 4. New x is 4. So we print 5. 4 is not equal to 2, so we print 4. X becomes 3. We print 3. X becomes 2. 2 fails. So we just print out 5, 4, 3, which is C. What's the result of this class? Again, classes, functions, ways to organize and store data structures, data variables, and functions within kind of one object. In this case, we're instantiating a class with the values A and B. So A and B are stored as X and Y. When we execute the function print point, we're going to print X equals A and Y equals B. So it should be X equals A, Y equals B. Again, just reading that from the print statement. Big idea with classes, know how it's organizing and providing reusable, almost like objects or containers for not just functions and not just variables, but both. We can store variables and functions inside of one specific class. A few more was the output of the following line of code. Enumerate ABC. This returns I, the index, and X, the value. So we're going to print I, the index. Then we're going to be printing 2 times the letter. As we showed in class, 2 times the letter should actually just multiply it. But maybe we don't remember if that actually works or not. You can totally, in your lab environment, you can make new notebooks. So that's kind of what I added here was that I created a new notebook just called Quiz Practice, where we can just check for some of our like NumPy questions that'll come up. So let me actually just run this. And I want to try the 2 times a string one as well. So here's our stop mic. We just put the code in and executed it. But let's try multiplying 2 times the letter A. That does return AA. So back in my quiz now, I think this is going to print 0 and then double A, 1 double B, 2 double C. So that should be D. Next one was the outcome of the following lines of code. Let's say you have no idea how NumPy works. This is where your quiz practice can come in handy. We can navigate back to a notebook. And here's where I have that question. My first array is going to be this matrix of -1, 1. Second one is 1, 1. We're going to do some linear algebra, some matrix multiplication. We dot multiply them together and we get a value of 0. Behind the scenes, I'm pretty sure it just like cross multiplies as the value, which all cancels out to 0.
It's
But it's
just
technically
yeah,
what,
it's vector
yeah.
multiplication. So it's like you multiply each item by each item and you add it together. So you end up in that case getting -1 plus -1 plus 1 plus 1, and that's 0.
Yep. And so big idea here is that if you don't understand some of the math or how the code works, then you can execute the code in your own notebook
Run the
environment
code.
and still be able to get the result.
Yeah, just run the code. I don't think we expect you to remember your linear algebra.
Yeah, you don't need to memorize linear algebra. This is not a linear algebra course. How do you perform matrix multiplication? Again, all you need to know is dot. You may put the star here, but that's just regular multiple. I don't think that'll be real matrix multiplication. Big idea, NumPys, matrices, linear algebra. To use NumPy as much as you can for anything that's related to matrices or linear algebra.
Yeah,
So the
all
answer
the
here should be the dot.
yeah, the three other options are all element-wise operations on the matrices. So you'd just
Yep,
be adding
exactly.
each element, so or multiplying each element.
So we're just gonna
The
whiz through the
alternative,
next
the
ones.
alternative is you can do A with the at sign, B, where NumPy
Yep.
will recognize that as matrix multiplication.
So let's do the next one here. This is kind of a funky one. This is a double nested matrix. Yeah, I already have it in my notebook here. So array out is going to be the array 1, comma 2, but how do we get that? First, we're going to be grabbing the rows 0 and 1 so we're grabbing 2 rows from column index 2. So we only have 2 rows. Our first, so if I had to write this out if I had to write this out like in Excel or something, our first row is going to be uh, 1, 0, 1, and our second row is 2, 2, 2. So this is asking us to take the first 2 rows of column index 2, which is column index 3, right? So we start counting at 0, 1, 2. 0, 1, 2. Column 2 is this last values right here. Grab the row values of row 1 and row 2. That's just going to be this 1 and then this 2. So that creates this array 1, 2 here. So let's mark that off. That should be D. What will the value of Z take? Again, this is another dot multiplier, so we're going to be lazy and just shove that into, oh yeah, there's X, and shove this into a list. Oh, this is the typo, right?
Yeah, this
So the
one is
parenthesis
it's
was never
missing
closed in
the
X.
parentheses. Yeah.
Yeah, so the parenthesis was missing an X. So note that if you copy this code over. But the output of this dot multiplication should just be 2, 2, 2, 2. So we should be able to grab that as D as well. Consider the following text file, example one text. What's the following lines of code do? With open text, we read it and then we print it out. I think it just prints out all of it. Did I try doing that in my notebook? I didn't. I think it prints all of it, but I may be wrong.
All of it, all three
Yeah.
lines. Yeah.
I was usually I would do read lines here, and that would make this make more sense because these are each individual lines.
Yeah,
Technically, this reads it
read
all
is
as one string.
yeah, and they'll have
So
line breaks in them.
I think they would have been new line characters in this string. I guess that would have been printed out as a new string. So I think it's A, it just reads the whole content of the text file.
It is.
Python library used to plot graphs is matplotlib. We'll do that in weeks 5, 6, probably. What data structures do HTTP responses when we use APIs? That would be JSON, as we saw from our live lecture. JSON, though, is going to be lists and dictionaries. And HTML files, again, we'll cover this more in week 3. What does TD stand for? TD stands for table data, table cell data. They usually exist within TRs, which are table rows. So this would be an A, table cell data. What's the three parts of a response? You're going to have your status line, header, and body.
Yep.
Whew. There we go. So you're going to have your headers, and then the body is going to be the majority of the information, and then the status on whether or not you succeeded or not with a 200 or a 403 or something like
I
that.
previously did D wrong, but because
Yeah.
there's a HT headers and a space in the body, but where you have it before you have the header, you just have the status, basically at 200 or what, like 200, usually it'd be 200.
Now, by process of elimination here, it's
100, then
not
the
B.
headers, then a space, then the body.
Yeah, but process of elimination, it's not bookmarks history security. Encoding body cache could be it, but there's not really a cache that's part of a response. The response could have been cached on the server side, but on your response, you're not going to see any cache. HTTP headers, maybe. Blank line is kind of sus. I don't know if you'd always see blank lines, but you do see headers
Yeah.
and bodies, which is why D could work. But yeah, the better answer is going to be the header, the body, and then whether or not the request was successful.
You have the start, you have the status number, the header immediately after, and then there's always a space before the body. That's
Yep,
just how an HTTP
yep,
how the protocol works.
yep. Just to close this out, what's the purpose of this line of code in web scraping? Table.findAllName. We're looking for all TR elements, table rows within a table HTML element. So this will return all elements with the tag of table row. Again, none of these other ones make sense. There's no reference to PA or H1 tags here. So that should be my quiz. Let's finish the attempt and submit it. And let's see how we did. Hopefully I got 100 as well as Karen. Woo, 20 out of
Yeah.
20. So big,
Yeah.
yeah, biggest takeaway. There we go. Yeah, big it is on the quiz. Definitely, if it's running code, feel free to use a scratch pad, either in Google Colab or like in the IBM environment, like whatever you want to do, right? Just make you can actually run the code in the quiz. Don't feel like you just have to hope for the best. Use
Especially
process
if
of
the
elimination.
especially the
Yeah, use
matrix math ones, we don't expect you to do
yeah.
them.
Yeah, exactly. We don't expect you to do dot matrix multiplication in your head or on a piece of paper. Use the code for that. And then, yeah, use process of elimination as much as you can here and just try and run through things each logically. Big ideas to take away from week 2. Introduction to computer science programming and automation. You should know pretty well variables, data types, and data structures, including integers, strings, booleans, floats, date times, what have you, and dictionaries, lists, sets, and tuples. Your next one is going to be conditionals. How do we use if, else, and branching or control flow to navigate and do different actions in one code block? And then looping iterations. How do we do the same logic on multiple things or multiple times? You should know the difference between for loops and while loops. Finally, writing a full program, you want to minimize the amount of repetitive code that you write. The principle of don't repeat yourself translates into reusable functions that can be used across scripts and programs, as well as classes, which are more typical in object-oriented programming languages, OOP, like Python. Classes can again contain functions, but also can contain instantiated variables and data types and data structures in its memory too. Note that the second bit of week two introduced translating this idea of coding into data engineering and data collection. That is going to be more in depth in week three, which is why I breezed over it today. But if you had coding experience coming in, I expect you to spend more time on those data engineering notebooks 2.8 through 2.11. If you did not have much coding experience coming in, I expect you to spend more time on 2.1 through 2.7 in terms of those media sets. And hopefully we all catch up going into week three here, where we're going to be doing a deeper dive into APIs, web scraping, and data transformations using Pandas next week. Only a few labs to do next week, so it's a few notebooks, but each one you should be spending more time on than usual. Looking forward to seeing if anyone participates in the week two forums or the week three forums. I will publish this lecture live tonight, post it in the forums and to YouTube, and then we'll see you in week three later this week for kind of the introduction of the week as well as my recap and preview video. So Hinton, thanks for joining. Karen, thanks for the time. I got 1:30. I will see you all in a week. Thanks for the time and the dedication. And yeah, if there's any questions, I can stick around for a few minutes to take those as well. Thanks, everybody. Yeah. Good. How to close out? I still got the record on live. Cool. We'll shut down the recording here. Sitting here just for one quick second. We spoke a lot about the bonus materials or the other resources you can do in class, which includes the W3 schools, the Google program for Python and Pandas and stuff like that. These are all really good. I also highly recommend Kaggle and Kaggle Learn. So these are free micro courses that tie in directly with the boot camp that we're doing right here. So for example, Intro to Programming is pretty on par with the week two. Same with Python, that's pretty on par with the week two. Pandas is mostly week three, right? Data Viz will be closer to week five, week six. The SQL courses are going to be the ones around week four, week five. And then machine learning, that's going to be week seven, week eight, week nine, etc. Neural networks and machine learning explainability, that's all like week nine stuff. So if you do any of these Kaggle micro courses, each one will take you about like 3 hours or less. It didn't, none of them ever took me 5+ hours, but you get a little certificate at the end. If you post that certificate into the forums, Karen and I will keep track and you'll give you some bonus points on the final capstone project at the end of the semester, if that's of interest to you all. So definitely some motivation to do some of that extra learning on the side if you have the time and capabilities. Technically, you could do this with Google or W3 schools. I like the quizzes on W3 schools. Um, they'll actually do like, yeah, pandas, and you can do like a pandas quiz. And this will help you just like again reinforce some of the learnings and stuff like that. So Kaggle
Yeah,
Learn if you want some extra credits, pandas, Google, or W3 schools, Google if you just want some other crash courses.
I like on the W3 one where it gives you little work, a little space where you can experiment with whatever they're showing.
Yeah, and I think oh, this is the Google's Python class. Is this yeah, maybe yeah. Yeah, there's some good stuff through Google as well, for free resources. But yeah, definitely, hopefully you are just being curious. Hopefully this boot camp starts inspiring your curiosity about the wider world of data science and programming, and start supplementing that right now with some of these extra materials that we throw your way. Of course, these are all optional, but we will give you extra credit if that's of interest to you. I don't think we've had anyone ever submit anything, but again, maybe it's at least something you take with you after the class. All right. Thanks, everybody. Yep, not much to ask. No worries. Have a great day. Have a great night, and I will see everybody next week. Bye, everybody.